Today we are going to discuss one specific protocol of transport layer, that is Transmission Control Protocol, abbreviated as TCP. We all know that the internet model or TCP IP model has 5 different layers. If we look into a top-down approach, the first layer is application layer, next comes my transport layer, next is network layer, data link layer, and the lowest layer is physical layer. So today we are going to discuss about this particular protocol known as TCP, and these two slides we talk about what are the topics we are going to study today. We will start off with what is known as process to process communication, then we will move on to TCP services, then comes numbering of bytes, how TCP does that, then 3 important properties of TCP known as flow control, error control, and congestion control. We will discuss in detail. Next we will talk about the segment, how the TCP segment looks like, some options, then what is this checksum calculation, what about the TCP connection setup and termination, state transition diagram, operational diagram, TCP package. These are the few things we are going to discuss today. Now let us proceed with or start off with what is my position of TCP in my TCP IP protocol suite or my internet model. So next we are going to discuss TCP operation and finally TCP package. Now let me start off with the position of TCP in TCP IP protocol suite. As I told you that there are 5 layers in my internet model: application, transport, network, data link, and physical. So TCP is my transport layer protocol which is responsible for reliable transmission. We have in subsequent slides we will discuss about it, that how TCP ensures reliable transmission, but today's discussion will be based on this detailing of this protocol only. Now this process to process communication, let us explain it with an example. Say I want to access the copy of the home page of Google. Now what happens? From my own computer, either a laptop or a desktop, I will open up, say, the Chrome process, browser process, and in the address bar I will type out the URL www.google.com. Now what happens next? This particular process, that is my browser process, gets connected with my server application process. So if we look into this diagram, this is my machine, for example, my own laptop or desktop, and this is my so-called Google server. So I am using my Chrome process to get connected with the application server process at the so-called machine known as Google server. So in later stages we will learn the network layer technologies. There we will learn something known as IP, but as of now the job of the IP address is to deliver that data from my machine to the Google server machine and get the data back from Google server machine to my machine. This is the responsibility or the domain of my internet protocol or IP protocol. Whereas today's discussion is about TCP. What is the responsibility of TCP? In my machine there are numerous processes running, whereas in the Google server machine there can also be numerous processes running. TCP's job is to take the data from my machine correct process, that is Chrome process, to Google server machine's correct application server process, and do the reverse job, that is getting the data from the Google server process to my Chrome browser process. So this particular job responsibility lies with TCP, process to process delivery. My browser process, as an example, from my browser process to the Google server application process, again from the Google server process to my Chrome browser process. I hope all of us understand that if I am sending a request of a Google homepage, copy of the Google homepage from my Chrome process, we all take it for granted that the response, what is the response? The copy of the Google homepage will come back to my Chrome process only, and it will not go to, say, my Notepad or Microsoft Word, those other processes. So this particular delivery is responsibility of my protocol of TCP. We can correlate with, as an example, say I am writing a letter to you, a physical letter, and you reside in a high-rise building, high-rise residential building, which has different floors. Each floor is having different flats. Now, if I want to deliver the letter to your name, your flat only, say your good name is Abhishek Chatterjee. Now, there can be multiple Abhishek Chatterjees residing. So, how will I identify? I will identify by the flat number. Say flat number 3B, Abhishek Chatterjee is the intended recipient of that particular letter. So if this happens in our day-to-day life communication, computer has been created, discovered, and all the technological support given by this particular domain, that is computer science, is to help our day-to-day needs. So the communication we are talking also works in the same line. Later on we will discuss that if I need to send one particular data packet, we will introduce that term later again, but this packet, some message, if I want to deliver from one place to another place, I will be needing 3 different addresses: IP address, MAC address, and port address. Anyway, let us proceed with another example, say the Telnet part. This, say I am trying to connect to a Telnet server from my own machine. So just now I gave you the example of sending a letter to Mr. Abhishek Chatterjee residing in flat number 3B. Same here, when I am sending the request to a Telnet server, I must know 2 things. 1, the IP address of that machine. Number 2, the port address in which my Telnet server process is running. Who gives me my IP address of the Telnet server machine? DNS will supply that. It will give me that process. DNS, basically I can consider it as a register. What is that register does? Say like your attendance register, where your roll number and your name are mapped. Roll number 1 such and such student, roll number 2 such and such student. Similarly, DNS, when we learn in detail about those, we will find out it is just a name to IP address mapping, and there is a technological discussion which we will do about DNS. In one liner, it will provide me with the IP address of that machine, but only IP address will not help. What needs to be done? I need the network port address in which the Telnet server process is running. So this port number needs to be a standard port number which is fixed for Telnet server or default for Telnet server process. That number is 23. For example, your HTTP server process, it runs in port number 80. So when I am connecting, the first example we took, that trying to connect to a Google application server process, my communication will be to the HTTP server port number 80. Whereas, say I am writing you the letter In that letter I will write my address so that you can reply back to me. Similarly here, the request which is going from my machine to the Telnet server machine, I will have a dynamic or an ephemeral port number in which my Telnet client process is working. In the request which I am sending, I will append my port address. For what? When the response comes back, it will come back to that particular port address. Last slide we talked about that this process to process communication is the job of my TCP protocol. So this port address is dynamic or ephemeral port address which is appended in the request which is being sent to the server process. Server port address is standard or default 23 for Telnet. In this request, I have received both the addresses, the address of the port and the address of the machine. Once I receive that in the server generates the response, sends it back to the original machine who requested and to the process which requested that. Next, TCP service. How does TCP implement this whole thing? And this is easier said than done. There is a lot of technological things happening at the background. Say this is my computer which is situated or located at Kolkata, that is eastern part of India in Asia, and this machine is my, say, Google server based in, I'm not talking the national mirror of that server, say the original server located somewhere in United States. So I hope we understand this distance is basically in thousands of kilometers. Fine. Now this is my Chrome process. First example we are talking of, and this is my Google server application process. What is to be done? Let us go back one step and discuss the previous day's discussion on HTTP protocol web page. I hope all of us have seen that when I am trying to view a copy of the home page of Google, the user will only be satisfied with the full page, and I will not be satisfied with a Google home page where I don't have the search bar, for example, isn't it so? So basically I will be needing the reliable transmission at both the ends to get the full amount of data delivered to the respective machines. Let me re-explain. That is, I should be able to have the full web page displayed in my terminal, be a desktop or a laptop. To ensure this, I need to have, TCP needs to have a stream of bytes to be transferred. We will go into the numbering subsequently, but it is like this. TCP creates a logical pipe between the sending process and the receiving process, and that pipe will be used for getting the reply back. When it replies back, I hope we understand, this becomes my sending process, this becomes my receiving process when I am getting the reply back from the Google application server. Now, just now we talked about these two are thousands, can be thousands of kilometers apart, can be few meters apart also. How does it implement the stream? Sending TCP is a full duplex protocol. Full duplex in the sense, I hope all of us remember that transmission can be of three types: simplex, sender keeps on sending, receiver keeps on receiving; half duplex, sender and receiver, both the entities can send, but they can send one at a time, they cannot send simultaneously; and the last one is the full duplex communication, when both the parties can send and receive simultaneously. So TCP is full duplex in nature. Sending TCP the buffer, we are representing it as a circular buffer. It has three parts, three types of cells, as you can see here. One, and this is like three color coded, one is white, another is pink, another is ash colored. White cells, white blocks, the empty ones, as you can see here, next byte to accept from the sending process. Pink ones are the ones which are already there in the queue, which are the next byte to be sent, and the ash colored ones are the ones which has been sent but not yet acknowledged. We are introducing a term here, acknowledgement. At the beginning we said TCP does the job of reliable transmission, is responsible for reliable transmission. How does it do it? Only through the acknowledgement message. Let us remember one point. In TCP, except one type of message, all messages are acknowledged. I repeat, in TCP, except one particular type of message, all messages are acknowledged. And which type of message is not acknowledged? An acknowledgement is also a message, but acknowledgement messages do not get acknowledged. I hope we understand the reason. Very trivial. If we keep on acknowledging an acknowledgement message, we will go in a vicious loop that will keep on going round, round and round. So, acknowledgement messages in TCP are not acknowledged, else all other messages get acknowledged. So, this ash colored ones, the color coded ones, as shown here in this pic, they are the bytes which are already sent but yet to be acknowledged. Let us come to the receiving buffer, receiving TCP. There are two color codes shown here. One, the pink colored one, which are the bytes we have already received, and those are being processed to be sent across to the receiving process. And the white ones are the blank ones, where we are ready to receive the next byte. This is more or less the structure of sending and receiving buffer of TCP in very simple terms. Now, we introduce another nomenclature known as TCP segment. In transport layer, the nomenclature used for a message is known as segment. And in couple of slides back, we discussed that TCP creates a logical pipe to send this stream of bytes from the sending process to the receiving process. How does it create? One of the properties used is making the segments numbered. As you can see here, this sending buffer will send the segments in a numbered order to my receiving process. Queries may come from your side, sir, you told few minutes back this is thousands of kilometers apart, these two processes, these two machines which are running these two processes. Yes. Sir, how do we ensure that all the segments being transmitted will be delivered? Because TCP is responsible for reliable transmission. We will discuss those in detail in the subsequent slides. But for the time being, let us take that these message chunks are known as segments and those segments are being numbered. Okay.